Hi Professor Chen, this is my first video of last homework, and this video is about the question 1. The question is the stochastic process Xt is real WSS with autocorrelation Rxs tau and power spectral density Sxs omega. And we need to show the first Rxs tau is real and even. And based on the definition of autocorrelation of xt, the Rxs tau is equal to this. The Rxs tau equal to the ext, then multiply the xt plus tau. And we know that xt is real WSS, and of course the xt plus tau is also real. So in general, the Rxs tau is real. And with both of xt and xt plus tau are real, the ext multiply the xt plus tau is equal to the ext plus tau, then multiply the xt. And based on the definition, the right part is equal to the Rxs minus tau, which means in general, Rxs tau is equal to the Rxs minus tau. So the Rxs tau is even, which is apparently. And the second question is Sxs omega is even and non-negative, and we know that the power spectral density Sxs omega is equal to the Fourier transform of Rxs tau, which is like this. And then we can just expand the right part, the expression of this, like this. It's composed of two parts. The first part is the integration of r tau multiplied by the cosine omega tau, and the second part is r tau then multiply the sine omega tau. And we based on the first question, we prove that Rxs tau is even function. And apparently the sine omega tau is odd function. So the even function then multiply the odd function is odd function. So apparently the integration of this part from negative infinity to the positive infinity is equal to 0. So there is only one part left for Sxs omega. So the Sxs omega equal to integration from negative infinity to the positive infinity of Rxs tau, then multiply the cosine omega tau. And we know that Rxs tau is even, and cosine omega tau is also even function. So in general, the integration of the whole even function is even function. So the Rxs tau is even. And the second part is we need to show that the Sxs omega is non-negative, and in order to solve this question, we need to recall for linear system. And as for linear system, the Syy omega equal to the Sxs omega, then multiply the h omega square. And we can use this to calculate the Eyt square, which means we need to inverse Fourier transform of the right part and let the tau equal to 0. So the Ryy0 is equal to the Eyt square. And so the Eyt square equal to this. And with tau equal to 0, which means the e to the negative j omega tau is equal to 1. So we just cancel this part. So Eyt square is greater than or equal to 0, and the h omega square is also greater than or equal to 0. So in order to make the Eyt square, the outcome of this expression is greater or equal to 0. The Sxs omega is greater or equal to 0. So in general, the Sxs omega is non-negative.